This lesson is throwing and creating custom exceptions. So I've talked a lot about how .NET can throw it up to the next method that's available, and if there's no next method, it's just part of the .NET runtime. That's called exception bubbling, where the exception is thrown to the calling method. And the calling method is ultimately the .NET runtime. So if you don't have a method in between what you're calling and .NET, then .NET gets it. If the method has no try-catch, then .NET just handles the runtime exception and calls it an unhandled exception and throws that error. And again, what you get at runtime is kind of going to depend on the application that you're creating. If you only handle specific exceptions and not the generic exception object, the exception is also bubbled up to the calling method. So, for instance, method 1 has exception handling. Method 1 calls method 2, and in method 2 there is no exception handling. Then let's say we had that code like trying to open a file down there in method 2. If an error occurs there, then the exception simply bubbles up to the catch block up in method 1. That's how exception bubbling works. There are cases where you might wish to throw the exception yourself, and we do this with the throw keyword. This keyword allows us to bubble up a specific exception. We can specify the exception to pass back. We use the throw keyword by itself, and that simply bubbles up the current exception. And we must always use the throw in a catch block. And the reason why is because that then lets us do the exception bubbling. If you use it in one of your try blocks, it simply goes to the catch block within your try. But again, same rules apply. If you're not catching that specific exception in that catch block within that code, it's still going to bubble it up. So lots of ways that bubbling can happen. So we're going to add the throw in the try block to pass to our current catch block, like I just said. All right, let's take a look at throwing exceptions. On line 9 and line 10, you can see a catch, and all I'm doing is throw with a semicolon after it. So what that means is it's going to figure out what the current exception is and throw it up to whoever called this part of the application. Now, in my case, Visual Studio is calling it. It ultimately was the .NET runtime. It gets the error. .NET then passes it to Visual Studio for me. Now, I've added one more little thing here. On line 3, I declared the file name outside of the try block. And I want to talk about why I think it's a good idea that you declare your variables outside of the try. And the reason is this. The try block is actually a block of code, and anything I declare inside of a block of code is only valid within that try block. Look it down on line 15 right now. We're getting a red squiggly, which means it says, well, file stream does not exist in this context because the try is its own block, the catch is its own block, and the finally is its own block. And we know that because of the open and the curly brace. So the problem with declaring things inside of the try is you do not have access to them in the catch block or in the finally block. And depending on what you're doing, that could cause some issues, like, for instance, trying to close the file stream. I'm a big fan of declaring variables, then acting upon those, and then if you have any sort of closure to do, you do that afterwards. All right, so if we were to now just run this, it's going to do exactly what it did before. It's going to throw that exception. It's going to bubble up to .NET runtime. The .NET runtime is going to say, well, I don't need to do anything with it. I'm going to throw it up to whoever's calling me, and that happens to be Visual Studio. Visual Studio takes that object and wraps it into its own little dialog that you see here. Now, a catch with a throw just by itself, this isn't real world, because if I take this out and I run this, I get the exact same result. It does the exact same thing. So this is really kind of superfluous code, basically. You don't want to do this. Instead, what you might do is you might want to throw a specific exception. So throw new file not found exception. I'm going to throw this one myself, but I want to give it my own error message. I want to say unable to open the file, and then in single quotes, file name. And now you see why I talked about earlier declaring the file name outside of the try block. I did this so that I could now use this within the catch block as part of my error message. Again, if I had declared this inside of the try block, you'll notice I get the red squiggly there on line 10. So that's not something you should do. And then to the second parameter of the file not found exception, you want to pass in the exception that you caught. So that's very important. That becomes now the inner exception. If I run this now we can see that I've got the unhandled exception, and it shows me that right here, system.io file not found exception. And then look below it, it says inner exception, file not found exception. So I'm throwing a file not found exception. This isn't that real world either, but I'm doing this on purpose because I'm going to show you what we're going to lead to next. Now, most likely, I'm not going to throw a built-in Microsoft exception. There's really no reason to do that because Microsoft is already going to be throwing that for the particular operation you're doing. But this is where you might want to create your own user-defined exception based on something that you're doing in your application. We do that by creating a new class. We inherit from the base exception class. We provide our own constructor to initialize certain variables. And then we can check in a catch block for our specific exception. Let's create our own class called FileToLarge_Exception. So what if in your application selecting files larger than maybe 100 bytes indicated an error and you needed to inform the user of that specific error? Well, that's where you add your own exception class, calling it FileToLarge_Exception. We watch for that exception, we catch that exception, and then we handle it how we want in our application. Let's take a look at creating our own custom exception. In our application, click on the project, right mouse click and add a class. Now we did this before we created our product class. This time we're going to create a FileToLarge_Exception. Now this is a standard that anytime you create your own custom exception class, make sure you suffix it with exception. Click on add, and now we're going to add our own custom class in here. I'm going to go wipe out everything that's here. And what I'm going to do is at the very top, I'm going to bring in the system.text namespace. And the reason why is I'm going to be using the string builder class. Then I'm going to give it the namespace C# samples. Now this is a little different. I'm actually putting a semicolon there when normally we would put the whole class within the namespace. However, starting with .NET 6, you're able to do this now. If all you're going to have is one class inside of a file, you're able to put the namespace on a line by itself. When I press the semicolon there, Visual Studio automatically takes out the enclosing curly braces. And isn't that nice? But that means you also cannot have more than one class in this file, or it's all going to be under the same namespace. Line 5, we create a public class called FileToLarge. We then use a colon and then specify exception. This is the symbol for inheritance. We are now inheriting all the properties and the methods for the exception class. The reason I'm doing that is I need to do that whenever I'm going to throw a custom exception. It has to inherit from exception. But now I can add on any additional properties or methods that I want. So line 6, I'm adding on public long file size. I'm going to put the file size in that the user was attempting to open. Then on lines 8 through 10, I'm creating a constructor. Now a constructor is nothing more than a method with the same name as the class itself. It doesn't have a return value. It's simply public and then the name of the class. And for exceptions, you always have to at least pass in the string. I'm passing in the string message and long size. I'm then going to call the base constructor that we're going to pass the message to so it can set the message property. And then on line 9, I take the size that I'm passing to this constructor and assigning it to the public property file size. Next, I'm overriding the default method called toString. So on line 12, public override string, toString, and what I'm going to do is build my own message in here. I'm going to use the string builder. I'm going to initialize it to 256 bytes. I'm then going to, on line 15, do an sb.append line, passing in the message. And then on line 16, append another line, which is the file size. And that's what's going to be returned from my version of the toString. It doesn't give me all the stack trace and everything else like the normal exception object, I am overriding that functionality. Now that we've created that custom exception, let's throw that custom exception and catch that custom exception and display the information from the toString method. In our program.cs, I've added on lines 10, 11, and 12. After I retrieve the file size, I'm going to check to see if that size is greater than 100. And if it is, I'm going to throw a new file too large exception. And I'm going to put as the error message the file name is too large. And I'm going to pass in the size. Now, what I've done is on line 5, I've given it a new file name. I took the C# samples.sln file from this project and I copied it to my d:\samples folder. Let's go ahead and set a breakpoint here. But before we run it, take a look on line 14. Catch file too large exception. And then we'll do the console.write line on ex.toString. So it will run our toString method. So let's walk this through and see how this works. I'm going to press F5. I'm going to hit F10, open it, and if we hover over size, we should see it's 1145. That is greater than 100. So we're now going to throw a file too large exception. Now look what's happening here. The size is 1145. It's getting passed into this constructor. I'm going to press F10 here. And it's now going to jump down to the catch block file too large exception. And if we hover over EX, we can now see that we get all of the information about the exception object. And we see the data, but we also see the file size, right? And there's all the rest of it, the inner exception, the message, the source, the stack trace, all of that's still there, but we have our new custom property added on too as well called file size. Then when we call the ex.toString, I'm going to actually press F11 to step into that. We can see that our toString is running. We're building the information from our message and the file size property. It returns that. And if we just press F5 and let it run, we now see our error message and our file size. Definitely something you want to use every now and then. It's not something you're going to use all the time, but creating your own custom exceptions for a business rule that you may want to enforce in your application is kind of a neat way to do things. In this lesson, we saw that we should always wrap code in a try, catch, and a lot of times a finally block. You can add as many catch blocks as necessary, and we use the finally block to run code unconditionally. And then you'll create your own custom exceptions as necessary. Like I said, not something you're going to do all the time, but it is very handy in certain situations. Coming up in our next lesson, we're going to take everything we've done now. We're going to create a C# application to read a file and build an array of product objects.